Hi students, this is N. Sriram, Associate Professor from Department of CSC. In this video, I am going to present a lecture on Structured Programming and Modularization of the course Computational Thinking for Structured Design. Let us see what are the objectives of this session. The main aim of the section is to learn about the structured programming paradigm, and then the objectives of the session is the instructional objective of the section is the first objective is to understand the structured programming paradigm, and then to understand the concept of modular design. So generally you may have doubt what is the advantage of learning these structured programming paradigm and modularization. Once you complete this session, you can able to describe what is the meaning of structured programming, and you can describe what is modularization, and you should able to design an application using modularization design. So let us start introduction of the session. So first of all, we will see what is the definition of structured programming paradigm. Here the paradigm indicates it is one kind of structured programming. Paradigm indicates one kind of programming. So structured programming is a programming paradigm that aims to improve the clarity, efficiency and maintainability of code by organizing into well defined structures. Here well defined structures means subroutines, procedures, loops, conditional statements like this. And the thing here is, when we follow the structured programming, it promotes the a disciplined approach of coding by using subroutines and control structures, and it organizes the code in systematic way. So as I told you, this is one kind of programming style. So by learning this programming style, we can code our application very clearly, very efficiently, and the code maintainability is also very easy. Why? Because it provides some principles and rules how to manage and organize the code in a systematic way. And let us see different aspects of this structured programming. When you think about structured programming, basically there are three main important features. The first feature is top down analysis. Here this is the first feature, and the second feature of the structured programming is modular programming, and the third feature of structured programming, structured code. Here these are three important features of any structured programming. Let us take our C programming language in example of structured programming. Let us see how and what is top down analysis and what is modular programming, what is structured code, one by one. So first let us see what is this top down approach. Let us see the top down approach. Here you students, here this is the very common thing we are following in routine work, that is a top down analysis. Here in top down analysis, what we are going to do is, generally the purpose of writing any problem is to write a solution to any problem. So when there is a problem in top down analysis, for example, let us take, if we have given a problem like this, in top down analysis what we are going to do is, we are going to divide the problem into smaller parts like sub problem 1, sub problem 2 and sub problem 3, like this. So we are not going to define the solution at a strength. We are going to define, or we are going to break down the problem into sub problems. And next thing is, the analysis always starts at high level and it drill down to the finer details. Like if we take an application to code, first we start the central logic and then we think about the data elements. Like that, the analysis starts at high level and it is drilling down to the final details. And the main thing here is, it mainly concentrates on decomposing a problem into smaller parts. Like as I explained here, whenever the problem is given, the problem is breakdown or decomposed into number of subproblems like subproblem 1, subproblem 2, subproblem 3. Here the main advantage of doing like this is each subproblem we can address separately and individually before integrating them into complete solution. So instead of I think about entire problem P, I can address the subproblem 1 and then subproblem 2 and then subproblem 3, so that I can integrate them into whole problem. That is the main use of this top down analysis. So in top down analysis we break down the problem into number of subproblems. If you look at this top down analysis, we can get some advantages. The first advantage is it simplifies the problem solving by breaking down the problem into manageable subunits or manageable subproblems. And another thing is it helping in organizing the code in structured code development. So that what happened in structured code development, we use some modules, we use some subroutines, we use some control structures, we use some conditional statements, so that we can organize the entire code in well mannered and structured manner. And the other advantage from the structured programming is code reusability. Here once one module was defined, you can see whenever we require that module, the same module can be reused. The reusability means once we define a code, the same code can be used so many times. So that is the code reusability that can be done by using this top down analysis. The next thing is reduce the complexity. This is another important advantage. How can it possible? Students, here if you look at the problem in top down analysis, we are breaking down the problem into subproblems. Instead of writing solution to a problem at a stage, at a complex level, we can break down the problem into subproblems, so that the complexity is reduced to the subproblem. The size of the quantity of the complexity is also reduced, so that what we can define the solution to each subproblem in lighter manner. It automatically reduces the complexity of the problem. So these are the four main advantages from the top down analysis. This is one of the important feature in the structured programming. So let us see the second characteristics of the structured programming. We will see what is the second characteristic of the structured programming. As we discussed, the second characteristics of the structured programming, modular programming. So students, if you see in structured programming, this modular programming is a very important. So actually the modular programming is one kind of approach we follow in developing the software. So what we do in modular programming, students, as we discussed in top down analysis, in modular programming we are completely divide the program into smaller subprogram, that is the reusable modules and self-contained modules. Those can be defined by using functions. Those can be defined by using functions. So here what the thing we are going to do, each module we can implement as one function. For example, if we have a program, like if we have a problem like P, if we have some subproblems like P1, P2, like that. Let us assume that P1 and P2 are the subproblems of P. Then we can implement this P1 as one module like module 1, P2 as another module P2. And I can say this module 1 is one self-contained unit and module 2 is another self-contained unit. And because of this, what happened, we can organize the code very well mannered, and we can maintain the code well mannered, and it can also improve the reusability of the code. For example, if I want to use this module at somewhere else, so it is an independent module, so that I can use this module anywhere in my application. So that what happened, it increases the reusability. So in modular programming, the main thing is we are breaking down the problem into subproblems. Each subproblem can be implemented as one individual module, and each module is a self-contained and reusable module. Okay, so let us see what are the advantages of this modular programming. The first advantage is code reusability. What is this code reusability? As I told you, the code reusability indicates writing code once and using many number of times. For example, we have defined a module M1 and I want to use this module M1 in many places. For example, I have defined a module to find out sum of two numbers like a plus b. Let us assume that this is one module. So whenever I want to find out sum of two numbers, I can call this module. I can use this module. For example, I want to find out 10 pairs of numbers, sum of 10 pairs of numbers, I can use the same module 10 times. That is known as code reusability. That means define once and use many number of times. The second advantage from this is it improves maintainability. Let us consider a problem. If you take a problem and if you define a problem at a stretch, what happened? It is very difficult to manage the code while debugging or while developing, because if any mistake was committed in the program at any instant of line, what happened? We have to validate entire program. So that what happened? It takes a lot of time and it is very difficult to identify where is actually mistake happened. So if instead of doing like that, if you follow this modular programming, we can define more than one module, so that without disturbing the entire program, we can go and modify a particular module, or we can go and define a particular module. Like that, it improves the maintainability without disturbing the entire application. The third advantage is reusability. Reusability means using the same code any number of times. Like that, we can get the advantages from modular programming. Now students, let us see how to design a small application using this structured programming and modular design. So here students, I am taking one example application, that is a simple calculator. So we are very familiar with the calculator application. Let us see. So now I want to design a calculator application using modular design concept. So as I told you, whenever we want to follow the modular design, okay, we have to define each and every module. That means what is the sub functionalities of the entire application we need to identify. For example, if we take the calculator, in this calculator we can define the sub modules like addition of the two numbers, subtraction of the two numbers, division and multiplication, and getting the remainder, or getting the percentage, or getting the some square root, like that. So if we take an application like calculator, all the sub functions can be implemented as one module. The first step we have to do, that is the first we identify the functionalities and subtasks. That means I can say addition is one of the subtasks in calculator, subtraction is one of the subtasks in calculator, division is one of the subtasks in calculator, multiplication is one of the subtasks in calculator, remainder is one of the, like that. Whatever the subtask we have, each subtask we can identify one functional entity or one functional module. The second step here, we have to define modular interface. We have to define interface to each module. That means, for example, if I take a add module in the calculator, what are the inputs given to that add module? What are the output from that module? And we not think about how it works, but we think about how we can provide input to the each and every module. For example, if we take add, so we have to provide two numbers, let us take 10 and 20. How to give 10 and 20 to this add module? How to give 10 and 20 to sub module? Like this. Like that, the second step we have to follow, define module interface, and the third step is we have to implement the modules. What the implement is? So to implement the modules in structured programming, particularly in C language, we have one feature, that is functions. That means we can use the functions to implement the modules, and I will explain you how to define a function. So for example, if you take students, here there are 5 modules in this application, so that I can define one function for addition module, one function for subtraction module, one function for division module, one function for multiplication module, one function for remainder module. Finally, I am going to define one more module or one more function, main function, which can drive all these sub modules. So finally, once I defined all these modules, I have to integrate all these modules as single application. So finally, we can get the complete application, and this is the way how we can follow the modular design when we want to develop an application, particularly by using structured programming model or structured programming paradigm. And now students, let us see, here we are always telling that the modularity is one of the important feature in structured programming. Okay, here the question is, how can we define a module? Here in particularly in C programming language, I am talking about the C programming language. So in C programming language, a module can be defined with the help of a function. So what is a function? A function is a block of code which performs a task. So here when you think a function, every function can perform a task. That means, as we discussed in earlier slide, we have like addition, multiplication, subtraction, division, like that. Each module can be defined as one function. Here you can see addition module, I can define as add function. Subtraction module, I can define as a subtract function. Multiply module, I can define as a multiply function. Divide module, I can define as a divide module. So with the help of the functions, we can define the modules. So if you look at this code, this is the example of defining a module. So if you look at the code, we can call this is nothing but the specification of the function, or we can call it as prototype of the function. So what it indicates? Here it indicates what is the output or result from this function, and what is the name of the function, and what are the inputs to this function. If you look at here, if you look at this function particularly, it is giving a number as output, integer number, and its name is add, and it is taking 2 integer numbers. So that's like that we can give the specification. Once that specification is given, we can define a function like this. So here it indicates that int, that means the addition function is going to perform addition operation between 2 integer numbers. 2 integer numbers means 2 integral numbers. For example, let us take a equal to 20 and b equal to 30. Now what happened here, this 20 will be given to a and 30 will be given to b. Now what happened here, this is the a 20 and this is the b 30. Now this function, in this function I am defining the task. What is the task? A plus b, I want to do a plus b because I want to perform addition. So a plus b means 20 plus 33. Return means once the addition is completed, this function returns 50 as output. Like that, when you define any module, we clearly define what are the inputs to the module, what are the outputs from the module. That means we have to define clear interfaces of the module. That is very, very important. So actually here we may have doubt, how can we send data, how can we give input to the module, how can we get. So through the parameter passing, that you can understand when we are working with functions. Parameter passing is the technique to use to pass the values from one function to the another function. This is the way how we can define the modules in structured programming. Next we will see what are the advantages of this structured code and what is the structured code, and this is the third important feature of the structured code. So the structured code is nothing but it is a well organized code, and here to do the code in structured and well organized manner we use some of the important features of structured programming, that is like control structures. Well organized and disciplined code can be done by using some of the components like conditional statements, iterative statements and functions. And because of the well organized code, it improves the readability of the code, it improves the maintainability of the code. And if you look at the advantage from the structured code is we can get the more readability and understandability. By looking at the code one can easily understand what is the code and what is the functionality of the code. And maintainability and debugging is also very easy. Maintainability means when we use some structured code or when we organize the code very disciplined manner, so we can easily maintain the code. Why? Because if any mistake was committed, if any error has been committed in the code, that particular place we can reach there and we can modify there, we can easily debug it. And the third thing is because of this decomposition and well organized components we have, we can perform reusability, and it is easy to extend the application scalability like that. This is the other advantage from the structured code. And let us see what is the advantage of this structured programming. So as we discussed, the main advantage of the structured programming is the structured programming provides an organized approach to develop the code. So this is very important thing. So some people automatically get the doubt why we use structured programming. By using this structured programming, one can easily organize the code, and it provides an approach, systematic approach to develop the code. And by using the structured programming we can improve the readability and maintainability of code. And this structured programming offers several benefits and advantages, as well as it has some limitations. And by understanding these principles and applying appropriately, we can develop an application very efficiently. That is the advantage of the structured programming. So before going to close the section, we will try to answer these questions. That is, what is structured programming? We know that structured programming is a programming paradigm which has three important characteristics. That is, first one is top down analysis, second one is modularity, third one is structured code. And the second question try to answer, name two key elements of the structured programming. So we can say two elements are control structures and functions. And how does top down analysis contribute the structured programming? So as I discussed in earlier session, this top down analysis break down the problem into sub problems. Instead of addressing the entire problem, we address each and every problem individually. And just try to provide a real time example, like you can take regularly we can observe on the road traffic signals. So you try to develop an application by using modular design and structure programming with the help of structure programming. So these are the terminal questions you can answer. By looking at, you can get the knowledge of what is the structured programming. Next thing is, so whenever if you want to get more than this information, you can refer some of the books what we have here. Some of the website links are also provided. you can use these links, and you can see these are the very good books you can use to understand the structure programming concepts and C programming. As a beginner, you can easily understand what is the structure programming with the help of this Dennis Rich and ANSYS C, and next E Balaguruswamy, and this third book, as well as we provide some links, you can use it. I think I think the concept is very clear. Thank you one and all, and I'm going to disclose this session, and thank you.